So I've seen a lot of crafters are mixing baking soda with paint to come up with this sort of cement texture to their projects to kind of upcycle them, I guess you'd say. So I had questions. I had so many questions. And my dad is a chemical engineer. So I'd love to pose these questions to him, even though he kind of goes into professor mode, but he loves it. So I'm going to share an interview that I had with my dad talking about the properties of the baking soda with the paint, which I kind of knew sort of a little what the science was behind it, but we go in deep. So if you had any questions about any of that stuff, be sure and take a watch. It's pretty fun. Okay, well, thanks for talking with me, Dad, my chemistry expert. So I've been watching lots of videos, and people are doing this paint technique where they mix paint with baking soda to make this sort of cement kind of, I don't know if you can see the texture there, but
I can see it.
It makes it look like cement. So I want to know from you, why does that work? And I have a lot of follow-up questions.
Okay, well, there are really three things we need to talk about. One, concrete, which is what you're trying to emulate. And a little bit about that. I'm not going to go into any of it in a whole lot of detail unless you want me to. Paint, particularly latex paint, water-based paint that they're probably using for it, is the second thing, and how it behaves and what's in it and is involved. And third, of course, is baking soda or sodium bicarbonate or any bicarbonate or soda, whatever term you want to use, but baking soda. Okay. Shall we start with concrete? I think that's probably good because that's what we want to get. Okay. Concrete is really a composite material, and that's the reason why it looks kind of grainy and everything for it. Concrete consists of what's called aggregate, which is really rocks and stone, which are, like you might find in your driveway, that size, sand, and then some kind of a cement or adhesive. And usually it's Portland cement that will bind everything together, plus water. And because of the fact that and when it sets, that is when it starts drying, the cement, Portland cement or whatever it is, you can use other kinds of cements, but Portland cement causes the aggregates to bond to each other through the cement, and the sand just allows you to compact it together and everything. So you end up with something that is not completely homogeneous in appearance, or that grainy kind of mottled appearance that you're seeing for concrete, because of the fact that it's made up of various things that are bonded together. Now let's go to paint. You paint the surface, and normally what you're doing when you paint a surface is you want to have something that looks like a continuous film for it. And what the latex paint is, it's actually, again, a composite. You end up having what's an acrylic polymer, that is a film forming material that's emulsified inside the water system that it's in when it's in the wet state. Now, by emulsified, it's just like homogenizing milk. If you homogenize milk, what you're doing, you're taking the raw milk that tends to separate the cream into a different layer from the rest of it. What you're doing is you're breaking the fat particles up into small enough particles that you can then get them emulsified and stay in emulsion. And by emulsified, what you're really doing is you're taking other molecules that are in the milk to start with, that one end of them likes an oil-based, the other likes a water-based, and it sticks the oil-based part into the fat and the water-based part out. And if you have the particles small enough, you have enough of those, that is the fat particles small enough, you have enough of those little strings, if you wish, that are sticking in with an oil and a water-based part, that it stays suspended. You're doing the same thing with paint. You're taking the film forming part of the paint, the acrylic polymer, and emulsifying it. But you're doing something else too. If you did that, you just end up with a transparent or kind of a nondescript film for it. So you're putting pigments in to be able to give it the color that you want. Pigments are solid particles that are really ground up very small and are usually metal oxides or metal compounds for it. And you choose the different ones for the color you want. Okay, so when the paint dries, the emulsion breaks and that film forming material forms the film that you call the film surface for it, and it has embedded in it those pigment particles that give it the color. Okay, that's the paint. Now let's go to talk about baking soda, or one of the common names, of course, is sodium bicarbonate, and let's use that term because it helps us a lot with it. Sodium bicarbonate is actually a lye, L-Y-E, molecule that has captured carbon dioxide. That is, it's a sodium hydroxide, which is lye, plus carbon dioxide forms the bicarbonate molecule, and it becomes a solid when it does that. You ground that up as a solid for it now. Okay. Now, what you want to do if you're making bread and you're using baking soda, what you have to do is you have to cause the baking soda to give up its carbon dioxide to cause the bread, the dough, to expand. But if you're familiar, and I know you are very familiar with baking because I've seen some of the great things and eaten some of the great things you can make, but if you're familiar with baking, you know that if you're going to be using baking soda versus baking powder, if you're going to be using baking soda, you need to add something to activate it, whether it's lemon juice or metal oxide or eggs or something else. What it is those are slightly acidic compounds that cause that bicarbonate to give up its carbon dioxide. And it's that carbon dioxide it's giving up that's causing the dough to expand, because the dough itself is kind of like the paint, that it's a film forming, if you wish, or an elastic material for it. And so it's giving off carbon dioxide, causing the bread to expand. If you didn't put in something that was slightly acidic, it's not going to do it.
Can it get old? Like if you have baking soda for a long time, if it's old, does it lose its effectiveness?
Yeah, because you're actually, some of it's giving up a little bit of its carbon dioxide, so it's losing some of its effectiveness for it. And it's like anything else, it can get old and not as effective. The difference between baking soda and baking powder is that baking powder is only 30% sodium bicarbonate, or about, and the rest of it are active ingredients and other things you want in it, so you don't have to add the acid to it. Well, anyway, let's get back. Well, go ahead.
Well, I was going to say, can you use baking powder to have this same effect, but maybe not as nubby?
You might, but the thing is let's go a little bit further and come back to that question.
Okay. All right.
So what happens when you put the baking soda in the paint? The metal oxides that are the pigment in the paint are the activator for that sodium bicarbonate to give up its CO2. So what's happening is in the paint is you're giving up CO2 slowly, and slowly is probably part of the word that I'm going to come back to, the reason why I wanted to come back to it. You're giving it up slowly, which is causing then the emulsion of that acrylic molecules or polymers that are going to form the film did not form as complete of a film. So it starts to look a little bit grainy and everything. Now, how fast you give out that carbon dioxide probably would affect how grainy it's going to look. And if you were using baking powder instead of baking soda, as you're asking about, I have a feeling it's going to be coming out a lot faster because you've got all the things you need there already for it. It would probably still work, but you might have to use a different ratio. Remember, when you're baking, you're using, well, probably less than 1% of baking soda within your total amount of material, because you got one or two cups of material and you put maybe a quarter of a cup of baking soda in it, something like that. And then if you had baking powder that's only a third as much baking soda, it's going to behave differently. It might still work, but it would behave differently.
Well, sometimes I see people say, well, add the ratio half and half, and sometimes they say, oh, just do it like a third. Does that really matter?
Oh, sure, because it's going to be, probably is going to affect how fast that carbon dioxide is being given off, and therefore how grainy or discontinuous that film begins to look.
Does it make it dry faster if you put more in it?
I doubt if it would cause it to dry faster, because the drying is really the water evaporating from the surface, and that's going to affect it. And I don't think the baking soda is going to affect that a whole lot. It might dry a little faster because you have carbon dioxide coming off and taking some of the water with it, but I wouldn't think it'd be a major effect. Maybe a little bit if you put more in.
Does the combination of the baking soda with the paint, does it affect the properties of the paint? Like, would it be more likely to chip? Does it sort of degrade the adhesive properties of the paint?
Well, I'm not sure it degrades the adhesive properties, because that's the acrylic polymer bonding to your surface, but it might, if you used a lot and really look grainy, it may be tending to flake off more. I'm not so sure chip, but more of a flake off or rub off more.
Okay. Are there any other household products similar to this that you could use that are cheap? Or it wouldn't have to be similar, but maybe would have an interesting effect, like maybe a crackling effect, or...
What? I didn't hear the last part.
Like a crackling effect or an aged effect or anything like that. Like, what about
good question. I wish we would have thought about that ahead of time. The effect you're getting is from the CO2 given off, and there are not a lot of other things that are going to give off the CO2. So the crackling effect you would get by just putting something in that I think that was not compatible with it. And as a result, something that is fibrous that you could put in, I suppose, could cause it to have more of a crackling kind of effect, because it would just be fibrous material, really well dispersed fibers, or like cotton or whatever else, or some of the fibrous things you have in cooking.
Like what?
Well, I was hoping you was doing a lot more cooking than me could come up with it. But
I mean, like, what if I ground up rice or something?
No, something like the pills you take for laxatives that are fibrous material. I put a little bit of that in there. Give your paint a laxative for it. No, I'm talking about the fiber pills that you use for laxative. That's
like Metamucil or something?
Material. What?
Like try Metamucil or something?
Yeah, something like that.
Oh, that's okay. That's a challenge.
Just put a little bit of that in, and it'll probably give it a crackling effect, because that is going to be something that is going to disperse and affect that film forming a little bit. Now, I haven't tried any of that, but
I'm game. Okay, so what about baking soda with like RIT dye, like liquid RIT dye?
Okay, now dyes and pigments are different. Pigments, as I described for the paint, were solid particles that are very well dispersed.
Okay.
And they are going to react with the sodium hydroxide to give off the carbon dioxide. Now, dye, you're putting the dye in, well, if it's an acid dye, well, RIT dyes are acid and others, it's going to activate the sodium bicarbonate to give off carbon dioxide too. So it probably would work. Now it's going to work different, and you got to play with it to find out how much of each to put in. But it would do much of the same sort of thing I think that the pigments did. Might even be more effective because it's in solution and the sodium bicarbonate went into solution.
So an experiment might be to use paint with baking soda and powdered RIT dye?
And yeah, or you could just put the baking soda, well, I wouldn't put the baking soda in the RIT dye because it'd give off the carbon dioxide right away.
Right.
You may put the sodium hydroxide, the sodium bicarbonate, the baking soda in the paint, and then add the RIT dye to it and stir it up and see what happens.
Okay.
Rather than, and that probably would cause it to give it off this carbon dioxide faster because now you've got the metal oxides in the paint, the pigments, causing it to give it off. The RIT dye, which is slightly acidic, causing it to give it off too, and it'll give you a different effect. And you might be able to use less sodium bicarbonate, less baking soda for it. It's all something you want to play with to get the effect. And the dye is going to give you a little bit different appearance than the pigment would anyway.
Interesting. Okay. Well, that's some fun stuff to try.
Yeah, I'd be interested to find out what some of your hobbyists do and how it turns out.
Me too.
I've never tried any of that myself. I can just tell you what I think should happen.
Well, come visit and we can set up
Let's
shop.
do it together, okay?
Okay. Well, thank you, Dad.
Oh, you're quite welcome. Anything else?
Did I forget anything to ask? Okay.
Love you, daughter.
All right. Love you too. I appreciate it. I'm Trista of Tried and True by Trista. So I would love for you to hit that subscribe button and hit the bell notification so you're notified whenever I have a new video, whether it's with my cute little dad or not. So thanks for watching.